Good morning. My name is Benoist. I'm a technology research specialist working for Natixis in London. And it is my pleasure to introduce this new session on the fascinating topic of battery innovation and supply chains. Energy storage has actually kept us pretty busy last year as we dug into grid infrastructure with my colleagues Ivan Pavlovich and Rita Boutros and analyzed the technological, environmental, and economic drivers behind the rise of BESS operations. Later this year, we're also planning to give you an update on the batteries for the EV sector with my excellent colleague Valentin Maury, and we'll delve into the specifics of onboard storage technologies. Feel free, of course, to get in touch with any of us if you would like to discuss or receive any of our recent publications on these topics. As you can see, there's always a fair amount of content for you to explore, should you wish to do so. Today, however, I would like to address batteries as a more strategic topic that goes beyond the simple notion of energy storage. The accelerating energy transition is exposing critical supply chain vulnerabilities, most notably a heavy dependence on China across the entire battery value chain, from mineral extraction and refining to system assembly and pretty much everything in between. In Europe, building a sovereign and competitive battery ecosystem has proved rather challenging so far, to say the least. We'll try to understand why and see if lessons have been learned from past mistakes. Another question will be whether innovation and technology can, on their own, reset the global balance of power. There is so much happening in this field right now, from the development of alternative chemistries to creative software solution and distributed implementations. Are these credible and useful deployments, or are we just in the middle of yet another hype cycle? We will also discuss recycling and second life application as a means to strengthen industrial independence whilst keeping environmental impacts under control. Now, quite a heavy program then, but fortunately I am joined today by a remarkable panel of experts to help me go through it all. Starting with Anna Teyssot. You are a managing partner at Exergon, a European venture capital firm investing in deep tech solutions for the energy transition. You bring more than 20 years of experience across electrification, batteries, and industrial scale-up. You began your career in 2005 at Renault, where you spent over a decade in battery R&D, e-powertrain engineering, and corporate strategy roles. You later served as Venture Development Director at Alliance Ventures, the group's corporate venture capital arm, leading strategic investments and partnerships with mobility startups. In 2021, you joined Verkor, where you led sales, marketing, and product strategy to support the company's industrial and commercial ramp-up. You hold a PhD in physics from École Polytechnique. Yasmine Assef, welcome. You are a senior principal at Afry Management Consulting. You have more than 25 years of experience in the energy industry, having started your career in the field of energy management systems and smart grids at Alstom, and worked for Renault as an energy services program director, leading the design, deployment, and operations of charging services for electric vehicles, including vehicle-to-grid and smart charging, which we will be talking about later today. You hold a master's degree and PhD in electrical engineering. We then have Gaëtan Depaëpe.
Good morning.
Good morning, Gaëtan. You are a repeat founder and CEO with over 20 years of entrepreneurial experience. After building and exiting earlier venture, you shifted your focus to climate and energy deep tech. You now lead Entroview, developing physics-based battery intelligence to enable insurance, financing, and scale in electric mobility. And finally, Luc Pez. Welcome, Luc. You have more than 25 years of experience in investment, fundraising, and industrial strategy for institutional clients and projects in the battery and critical minerals value chain. Before joining Viridian Lithium as Chief Commercial Officer, You oversaw Vercor's raw material sourcing activity and contributed to the Gigafactory 1 Series C funding. Ladies and gentlemen, before we get started, please remember that you can ask any question on the sidebar of your screens. We shall try to answer as many of them as possible before the end of this session. So Anna, let's perhaps start with you. And before going into battery technology and taking a look at what may or may not emerge as a revolutionary breakthrough for energy storage ecosystems, it could really be useful, I think, to take a few moments to analyze and review the state of industrial efforts in Europe in those domains. And battery have long been identified as a key enabler of the energy transition, yet building a sovereign, competitive battery industry has been rather complicated, as I was saying in my introduction. And there's a general feeling that we've been going from setback to setback and more setback, culminating of course, in the Northvolt bankruptcy last year. Why is it so difficult to compete, and what lessons have been learned from past mistakes?
Thank you. Very good question. And truthfully, everybody is struggling with ramp up. And this is crucial because it is a very capex intensive phase. We know about Northvolt that was late in delivering the cells, so delaying the revenue phase. We know ACC and Vercor just started, so certainly facing challenges, although the first trials are great. But also Asian players that localize in Europe struggle just in a similar way, and sometimes even if the plant is carbon copied in Europe, there are yields that are as low as 40, 50, 60 for years. So this can be a very, very intensive, I would say, expensive phase to go through. There are a few maybe lessons learned and tips and things that can help. I can speak having lived this phase in Vercor. There was an early investment in a pilot line, and this was absolutely crucial to have this pilot line as close as possible to the production line, to test the processes at capacity, so with very high cadence. This is very, very important for the problems to be actual problems that you will see in the plant. The equipment ideally needs to be similar or with the same sourcing. There has been of choice to go with equipment makers that were Asians, but not the least expensive. So there was a strong Korean process team in Vercor that enables during the ramp up to have good communication with the equipment maker, and it's after service. The months following the ramp ups are completely key, and there needs to be a great communication during that phase. Another aspect is certainly having a kind of access to the process data. So today the sensors are so cheap that they're everywhere in the process, the manufacturing. You have this data, but it's usually there to be stored. And if you have an incident in the field, years later, you can go and tap into this data, and it's what OEM standards required. You go and see what happened. But if you have actionable data, meaning that you're not blindfold, but throughout the process ramp up, you have the visibility on what's happening, this is a great help to identify the problem and even to identify optimization opportunities. So that's one other. And finally, maybe Northvolt was into different geography, even across the ocean, having a concentrated focus on one product, on one first plant to be operating, obviously helps things. So this is in a nutshell.
Follow up on that. I think the point you're making, which is a lack of focus, let's put it this way, or the kind of dream project that everybody has been very keen to fund for this main reason, low carbon, but at the same time trying to cover every aspect of the chain. This raise or multiply the execution risk associated with the project, which in itself was already hard to execute. So it was poorly executed, we all know that. But I think it's one big lesson, being focused and execute well, for one. Second, I would also highlight the contracting versus qualification realities, because we are all pushed by bankers, investors to have offtakes, binding offtakes, etc. A binding offtakes means nothing until the plant is qualified. And I think this needs to be taken into consideration, because the qualification process is very hard and long to go through. And I was talking about the ramp-up. I think it goes along that as well. Generally speaking, I think all this also ties to let's put it this way, kind of short-term viewing of OEMs, the way I view it from my side, which I've been promoting some of those projects, chasing NMC technologies. We'll probably discuss that later on, back in the 2020s, yes. And then you end up with a change of chemistry approach, which means that you remove some of the support of a client and tie it back to the fact that investors, bankers are pushing to have these offtake secure, sometimes with one client, and what goes with it adds further to this kind of risk. And the final point maybe that I would like to raise is that I think Europe is missing the fact that China's dominance today has been engineered for years. It ties on the technological advance, the critical size they've reached, and the vertical integration, which means long-term thinking. And that's something we are crucially lacking, I think, but we'll probably discuss that further.
So, Yasmine, would you like to add anything? Or?
Nothing at the battery manufacturing level, but just one point on making the right use of what is already produced, and we're going to get back to that later. Yeah.
Okay, so perhaps, Luc, let's go back to what you were saying, because you probably know better than anyone at this table how difficult it is to develop local industrial capabilities. And at Viridian Lithium, you were actually trying to develop a European refining capability for lithium, which is a domain which is outrageously dominated by China, a country which has probably more than 90% of the refining capability in the world, right? Tell us perhaps a bit more about your company, the vision, and perhaps how strategic in nature its mission can be for the continent, and what it will really take to compete with those Chinese competitors.
So let me first start to introduce maybe Viridian Lithium. So that's a company which was founded back in 2021. We are now 15 strong. There is a state-of-the-art lab. I think it's a bit like the pilot scaling. It's, I think, an essential tool to really understand the chemistry, the flow sheet that you need to develop. And that's a long journey to get there. We are so developing a project in Alsace, eastern part of France, of a lithium conversion facility. So no extraction, only conversion, focusing on transforming carbonates, so intermediates which are already highly concentrated, so minimizing the environmental footprint of transportation into Europe, if we source it abroad, into a facility that should have a 28.5 kiloton capacity of hydroxide. Why France? Because low carbon footprint, access to decarbonize energy, essentially. So that was the goal. And I think the other stronger feature of the project is the fact that it tries to meet the sovereignty issue that you're pointing out, which is that today China accounts for more than 70% of global refining. But if you look into hydroxide, you end up with the numbers you were talking, 80 or a bit more percent. So there is a clear dominance on this field, and how you circumvent that. That's part of the reason why I think the project has been selected as strategic. We were among the first 47 projects entering the CRM Act list. So that probably ties to the strategic and how strategic it is. What I would maybe highlight is that, and maybe I would like to take a bit of a step back, looking maybe more broadly beyond lithium, because to me, the kind of dominance that we are facing as an industry as a whole ties to the midstream. When you talk midstream, you're talking about the refining of rare earths, critical metals, and you can go all along those refining, but also to the precursor, the cathode active materials that goes into a battery, the anode that gets into the battery, the permanent magnets, and that's a part where China is dominating. 45% if you take refining of copper, 95% if you take graphite, if you take permanent magnets. So the key question is how you break that, bearing in mind that obviously most of those industries are not the highest return profile and therefore not that attractive from an investor standpoint. And second, some of those are subsidized. Which leads me to the final part of your question related to how you beat China. The way I listed it when I was thinking about your question is that when I see a Chinese competitors, it benefits from low OPEX, CAPEX. It has easy access to capital, sometimes public, R&D clusters everywhere. And now when you look at all the patenting numbers in China, I mean, this is crazy. Streamline regulation, which is changing and being adjusted every year. A quite big difference with what we do in Europe here, and long-term planning. If you look at this from a European perspective, it saddened me to say that we lack on all 5 metrics. So how can we move forward? I think, first of all, looking into a concrete application of the CRM Act from my part of the chain would be a good thing. As I said, we've been selected within this list back in April, so that's now 10 months ago. There has been a new initiative which is named Resource EU, announced in December. I'm still looking for the right contact person to make it operational. So that tells you a big story between the gap in rhetoric and how you make it happen. Then I think it's important to highlight that when you face the Chinese competitors, it's impossible to beat them on the capital intensity, on the OPEX side. That means essentially that as a producer in Europe, I can be the best on CO2 and whatever metrics that today OEMs are not really looking into or ready to pay for, let's put it this way. And the same OEMs are asking me to propose the same pricing conditions that the Chinese enterprise do, whereas obviously they're not facing the same constraints, permitting, etc., etc. So I think if you want to circumvent that, you need to have local content requirements. And that's something that I hope will be discussed within the Industrial Accelerator Act that has been pushed to February now. I think this is essential, and that's essentially playing the way China did back in the early 2000s by, let's say, authorizing the access to the European market in exchange for subsidies and share of the capital and transfer of technology, because I think this is an essential part of it. You can see some battery producing entities from China coming into Europe. Most of the time, it does not come with a transfer of technology. So I think we need to stop being naive on that front. And I think the other point I would maybe add is the deployment of capital at scale. That's something which I think is crucial from the public side to allow sharing with the private sector. And that's something we are definitely missing in Europe. I'm not saying that we are not helped. As a French project, we benefited from France 2030. We also were selected for C3IV, which covers 40% of the CAPEX. But one, this is a national initiative. It's great. But it's something we can make actionable when we go FID for the project. And then we need to go to FID. And that's the big vacuum today, which is for a project such as ourselves to be able to find the equity or quasi-equity funding to go to this Death Valley or past this Death Valley and move into FID. And that's where I think public funding would be most needed. And we are not talking about hundreds of millions or billions like you can hear for gigafactories and so on. Having allocated only 2 to 5 million euros to every of those 47 projects selected, and maybe the others which are chasing this selection, would have simplified our life a lot. Because when I look at my project, I have a project which is very shovel-ready and near FID, only 2 permitting left, but otherwise everything is secured. We need to fund that. This is DevEx. We are not having, obviously, any turnover. And this is something you cannot fund through subsidies or through debt. And this requires probably a bit of long-term thinking, which ties back to what I said earlier.
So, I mean, in that macro context, obviously, as you suggest, it's very difficult to go, head on against China, and perhaps to beat them as well, you have to think about being smarter on the technology side of things. And I'm turning to you again, Anna, with a question on battery chemistry this time. Lithium chemistries probably account for about, let's say, 85-90% of the lithium battery ecosystem, mostly due to high energy density, low cell discharge, fast cycling, and so on and so forth. But they also present a number of, let's say, limitation of well-known disadvantages, thinking of wear and tear, for those battery cells, thinking about perhaps shorter lifespan compared to other systems, thermal stability, higher material costs, environmental impact. We're going to talk about that shortly. And they tend to be used also for short duration applications. We see from 2 to 4 hours in most cases. So, sodium, vanadium redox flow, solid state batteries. There are so many great ideas out there, but are they really viable economically? Are they scalable outside of the lab? And within what kind of time frame?
No, great point. There has been a shift from a performance-driven innovations. So it was all about increasing the energy density, going for silicon at the anode, high voltage cathodes, for example, with a challenge on the electrolyte stability. It could have an impact, a positive impact on cost, because when you go euro per kilowatt hour and you raise these kilowatt hour, if you're reasonable about the extra cost these technology bring, it goes in the right direction. So higher energy density were good, but not enough. And the LFP, I would say, transition towards underperforming but very low cost option really triggered all of these efforts towards that direction. So the first one up, obviously, is sodium. There was this huge peak, Luc knows so much about it, on lithium, nickel. So people were buying their batteries that are contractually indexed on the raw material prices with plus 50%, plus 70% on their already done deals. So this was kind of traumatic and obviously triggered a huge exploration of alternatives to solutions that had less embedded volatility. So sodium there is great because sodium is okay. It does not rely on cobalt. It does not rely on nickel, lithium, of course. But fourth of all, it does not rely on copper, which is kind of strategic in the long term because the electrode current collector can be nickel on both sides, contrarily to the lithium technologies. So that was really a huge boom in development, so much so that a few companies actually dropped and went bankrupt, like Natron, in the years following the return of the prices. They found themselves with a mature product with underperforming characteristics because it is less energy dense and without a cost competitive because the supply chain is not there yet. And so there's no scale effect, and this was kind of critical in their ramp-up phase. However, has it the potential to be cost competitive? Clearly, yes. It has been inscribed in the long-term planning that Luc was saying is so important in the 5-year plan for China. So clearly that's one direction and a pretty, I would say, mature short-term one. Then if we go into longer duration, what is called long duration energy storage, well, there's it's very hard to beat LFP. So I would say that less than 10 hours, maybe today, it's difficult. Maybe this will be replaced by sodium when the time is right, but nothing very exotic. But if you go into the further than 10 hours, then you start to have these like hydro pumped, compressed liquid, compressed air, gravity systems that can be relevant until maybe 25 hours service. If you're going to want to go beyond that, the actual investment in terms of energy is huge, and you can only go to systems that decorrelate the power from the energy. So, for example, redox flow, the power is given by the electrochemical stack, and the energy is given by tanks that provide the electrodes. You have different systems, vanadium, iron, and zinc sulfur, for example, are a few of them. So that's the direction for the redox flow. Are they TRL, the vanadium one? Yes, there are a few trials, but still not clear if they can be cost competitive because the scale is so young. The others are more interesting from a cost perspective, the material used, but still pretty young. I would say TRL 4 or 5.
So you mentioned China. My view here is that even in those next generation technologies, they seem to be ahead of everyone. They seem to be already going with some demonstrator project at scale in China. So are we not already actually late in those domains?
Yeah, it's very difficult to beat China in product design. The IP is crazy, in fact. They are very strong also on solid state that we have not mentioned, but they have some commercial trials coming up. It's always shifting a little, so you feel there's not a complete maturity there and some challenges, but interesting stuff on the anode-less design with meshes where you strip and plate the anode, avoiding these metal reactive that are pretty difficult to handle in the manufacturing stage. So to check there. But I'd say that there's a lot going on in Europe, and that can be funded by VC, for example, around the process, dry coating process, for example. It's something Tesla bet upon, and I'm sure with manufacturing excellency and smart ideas, it's possible to work around that in Europe. There are some other designs. I was mentioning the importance of dealing with the data in manufacturing, the part on quality checks that are non-destructive, how to improve this yield ramp up, address the manufacturing challenges, virtual, I would say, twins of battery plants that can help efficiency. All this is worth looking into and can totally be European.
Maybe if I could add a word, I think that the sodium discussion is very interesting here. There were many startups looking into that over 2024, 2025. They all died because only cost was looked into. So again, referring back to the long-term thinking that I was discussing, China does not think this way. It always tries to have redundancies, different technologies, to be able to rely on different things if they are on time and on market. And presently, you have CATL, which is deploying at scale a sodium offering at a time where lithium price have rebounded by 130%. It starts to make sense from an economical standpoint. So I think, once again, Europe is very good at innovation, looking into startups, VCs, etc. But we are lacking this culture of scalability and redundancy. It's like as if we are always chasing a silver bullet kind of dream project, which kills all birds with a single stone. Right?
It's interesting. You mentioned solid-state batteries, but it's a good example as well. I mean, we've been hearing about those for like more than a decade. A company like Volkswagen has been investing hundreds of millions in QuantumScape technology, and this thing never seems to get out of the lab, really.
I did my PhD on solid-state batteries, so that's very...
Okay, so...
And that was like 20 years ago.
So how much longer are we going to have to... Because, I mean, this technology seems like a no-brainer if you can actually scale it and put it in those EVs, right? But so what's actually slowing things down?
Well, it's a pretty tough. It's great in capacity because you avoid this rocking chair graphite system that is like a sponge for lithium ions, and you replace it by lithium, pure lithium itself. So it's absolutely great in terms of capacity. The stripping and plating of the lithium of this surface is all the problem. The stability of the interface, the dendrites. There are several technologies for the electrolyte. You can go. It's actually a huge family. You can have polymer. You can have composites, polymer and ceramic. You can have ceramic that are oxides, sulfides. Seems like sulfides is a bit of the grail, but again, there is still a few years before it's and. I systematically have seen, because I was purchasing batteries for years, I've seen the roadmaps always systematically shift this SOP, and I have seen roadmaps of maybe 10 years from now where it was 2040. And now the commercial trials seems to happen. Usually they are based on polymer. They are sometimes quasi-solid, so a few drops of electrolyte are added to have the right conductivity. And it has another attractive thing, is that today there are a lot of invested capacity that are based on pouch format, especially in Europe. And these are quite, I would say, are adapted to solid state. So that's a kind of nice angle and a relevant one for Europe.
So beyond chemistry, there's also some rather creative ways of achieving mass energy storage, I would say, without installing thousands and thousands of stationary BESS facilities across the country. And I particularly like the idea of vehicle-to-grid, Yasmine, which is something that you know rather well, I understand. Mm. Could you perhaps explain briefly what vehicle-to-grid actually is and how it works?
Yeah, thank you for the question. The vehicle-to-grid is basically a concept of how you, technology that enables to get the energy from the battery and, pull it or push it from the battery and put it in the grid. Let's say from the battery of electric vehicles. So this is the whole idea of vehicle to grid. Sometimes we call it bidirectional cars. So usually you just charge, and this is the capacity of discharging the energy from the battery. And if we want to go into detail, you have the vehicle to grid, which is, or V2G stands for how can I bring service to the electrical grid, but you have also vehicle to load. It's a bit nerdy terms, V2L or V2B for vehicle to building, vehicle to home, where you put the electricity either to a load, so you just plug your device, whatever it is, your fridge, any devices that you have, you put it and you charge it from the car, or you send the electricity back to your house, and to self-consume your solar panels energy, etc. So that's the concept of vehicle to grid. But if we take a step back, the question is, why talking about this? What's the topic here? There are, I think, two elements here. One is the electricity grid that is in a profound evolution. In one side, and you had already topics around BESS and battery energy storage, but there is renewable in the more and more renewable, so that the renewable are kind of intermittent, and we need flexibility to cover that. So that's one point. The other point is that we have the load part, or the demand side, that is also increasing a lot, or we expect that the load should increase. Actually, because of any economical reason, we didn't see that growth, but there is the decarbonization of industry, there are the data centers, there are the electric vehicles and trucks and everything, so the demand would also grow. So between this, more intermittent energy, more demand, what we need is flexibility. And the flexibility can be brought by those little vehicles or little batteries on wheels that are everywhere. And if you're able to aggregate that, then you can propose a service to the grid. And then the bottom line is that this electric vehicle will not be a liability anymore. It will be an asset for the electrical grid. And that is the supposedly magic of it if we can overcome challenges, etc. And it's also a way of taking benefit of everything that we have already. These batteries are already in the cars. They have already been bought by people, and they are not used as the maximum of what they have. So before going to a second life topic, there is already in their first life a lot that can be done with this technology. Yeah. And the way it works, just to complete here, the way it works is that you have the battery of the car that has, again, going to the technical stuff, which provide a direct current. Okay, it's a DC one, so you need inverter to transform this to AC. And once this is transformed, this inverter should be bidirectional. So there is not a consensus between car manufacturer and the ecosystem in general. Some of them bet on that inverter being inside the car. That's what we call AC bidirectional, and this is what Renault and now Nissan is doing on their cars. But some others think that, okay, this inverter should be outside the car, so it's not my burden anymore, it's for someone else, so it's outside the car. But anyhow, you have to do this transformation, so you have to have the whole system. You have to have the car, the charging station to be bidirectional, both of them. And on top of that, you have to have software and IT technology too, and that's key to manage the whole story. Yeah.
I'm just trying to think about some numbers here, but I think I've read that today 1 out of every 4 cars, 25% of cars is now electric, right?
Between the sales, actually, one out of 4 that are sold.
Depending on the model, batteries are 100 kilowatt to 200 maybe?
No, smaller, but smaller, yes.
So,
but still,
multiply that by the number of cars, you end up with a serious capacity in terms of storage, right?
You have a serious storage capacity, and this number of the size of, and I'm in front of experts here, but you correct me if I'm wrong. The battery is 50 kilowatt hour battery, but it is not. I mean, the amount of energy that is in there is to make 150,000 kilometers, so it's much, much more. And if we look at numbers, in 2030 we expect to have something like 50 million electric vehicles in Europe. And in terms of energy that they need to charge, we are approximately about 150 terawatt hour of charging need. You just imagine you take 2% of it, that you extract only 2% of this, you end up with 3 terawatt hours. Yeah. 3 terawatt hour of energy that you can extract is the equivalent of a bit more than 500 offshore wind.
Yeah, it's very significant.
It is very significant. There has been a study by Eurelectric published last year. They were even more bold on that because they expect to have 140 terawatt hour by 2030, and this is if all cars are bidirectional, everyone is ready to play the game, etc. And that would be 4% of the electricity need of Europe. So that's tremendous. So I tend to say that this is a kind of infinite energy that you have.
Mm. And so, I mean, it seems like almost a no-brainer, really. What are the challenges, actually, to vehicle-to-grid implementation? There's plenty of hardware, software, aggregation, tax, grid management. There's so much, actually, to deal with, isn't it?
Yeah, absolutely. The biggest challenge probably is the fact that the ecosystem is complex. And to make it work, you have to have the whole stakeholder. I mean, all the stakeholders to work together, and there is a lack of interoperability today. But basically, when the main challenges are the fact that you need to have a car that is bidirectional ready. Today, not all vehicles that are going out have this capacity. Whether it's AC, whether it's DC, that's the same, but still automakers have to make sure that they authorize the energy to flow outside their battery. That is not yet here. Not that much because of technological reason, I don't think so, but probably lack of long-term vision, probably lack of clear business case that they're afraid to, the topic around the warranty of the battery, etc. So that's on the car makers. Then you need to have regulation that is here as well, mostly grid regulation that is associated to that. Until now, there was a topic about the double taxation. This is not completely, what is double taxation is the fact that, and the question was also for battery energy storages, but they have been removed somehow. But for the mobile storage or small storages is you pay the taxes to the grid, or taxes or grid connection costs, or you name it, when you charge your car and when you put back to the grid as well. So this is you pay twice for the same energy somehow. This tend to be also alleviated and facilitated in Germany. There has been last year, end of the year, good news about that. So, but there are double taxation. There is a lack of smart meters everywhere. You have to imagine, yeah, that to control this, you have to measure it. And these measurement devices have to be somehow stamped or validated by the grid operators. So regulation is here, yeah. Lack of clear business model is here. Lack of grid codes, not lack of grid codes. There is not homogeneous grid codes in Europe. When you manufacture a car, you have to have, there is one car that is driving everywhere, or if even you don't drive it everywhere, you will sell it in second hand in Poland or in Germany. So the grid code that is valid for France should be valid also for Germany, and this is not the case. So there's also these difficulties on grid codes, etc. So these are the main challenges here, and I would say that if we want to simplify it, the question is a question of control. At the end of the day, who is controlling the energy that is in the battery? Everyone is claiming, and that is maybe the reason why things are at this stage, even if vehicle to grid is a topic that at least in universities, at least we're talking about this for 20 years, 15 years. So technology can be here, but who will control this? And the control is the magic word here. The battery or the car manufacturer that is putting the battery in the car is the OEM that should be in control. Me as a consumer, a car driver, I want to be also in control. This is my car, I bought it, and I want to have the benefit of it, and I don't want someone else to control it. The grid operators want to control basically everything that is connected to the grid because of reliability, because they have to make sure that the grid is reliable. So that they want to have this control, but aggregator, they're saying that we are, monetizing this, so we want to be in control. So that is also the topic that is still challenging, but yeah, to make it happen, in my opinion, first of all, we need scale, and we need to make sure that the grid operators can trust on batteries from the electric vehicle to provide the services to the grid, different type of services, and they are reliable. And that's you can make it by going at scale.
And there's been already some interesting use cases of that in the US. I know with the school buses.
There are school buses in the US. That's
worked pretty well. So
yeah.
I have a question. Actually, I'm asking for my boss who just got a brand new Tesla. If I'm actually plugging into one of those schemes, is there not a risk that my battery is going to deteriorate faster? What's the, is there a risk there for?
First of all, I think that Tesla, he cannot use it bidirectionally yet. Might come someday.
Sorry, Thibault, you're not going to make money with this.
Might come one day. So if all the customers of Tesla are pushing, that might come. But there is an amount of energy in the battery. And if you cycle it too much, the question is how much you will cycle it. And if you cycle it a lot, of course, there is an impact on the battery. But the most extensive usage of a car battery, and again, under the control of Anna here, it's the driving, it's the acceleration. This is what, is really cycling a lot the car battery. For the use cases of that we think of for vehicle to grid, you can always control this and you can limit the cycles because there is an amount of electric vehicle and everyone will give a little, of it. If you want to charge your house with your battery, with your Tesla, yes, every day, that will certainly have an effect.
And this almost brings us to our next topic, which is battery diagnostic. We've discussed industrial deployments, advanced chemistries, distributed storage through smart combination of hardware and software. And we should not overlook, of course, the importance of diagnostic application. And that's where Entroview and you, Gaëtan, have interesting value proposition, right? And could you tell us a bit more about, your company, its vision, and the current roadmap?
Yes. Entroview is a deep tech startup, and we are building battery diagnosis. And I think this is what Yasmine said is really interesting, because if you see batteries as an asset, you can see something that you can extend the lifespan. You can have different type of use. And for the thing you just mentioned, if you choose the correct rate of charge and discharge, and you don't go too deep or too high, you can use your battery without nearly degrading it. But to do that, you need to be sure of that, because of course the money you will gain from your Tesla will not be so much. So you need to be sure that you're not degrading your battery. And that's our vision at Entroview. We want to make battery predictable. Okay? If you do that, you can make that more financeable. You can have better insurance. You can have better, safer use and reuse. And you know that batteries is the most uncertain things in electrification for EVs, but also for energy storage. But if you can tackle this uncertainty, in terms of finance, you can do a lot of things. Because actual batteries in cars, they can live 15 to 20 years. So you just need to be sure about what you're doing and the actual state of a battery. Because also, we have mentioned that battery is something quite complex. When you produce cells at scale, you don't have two identical cells, even from the same batch of the same day. So you need to understand batteries. In our roadmap, we're now starting by working with the end of the first life of batteries. Okay? We tackle a logistic pain right now, which is transportation, storage of used batteries is a nightmare. And as the flow is going, the volume higher and higher, that's something which is difficult for all stakeholders. And we tackle that, and at the same time, we're creating a unique data set, multi-brand of batteries, which help us in the future to get to predictive models, and so to finance, insurance, and so on. And for the first example, our next product will be diagnosis for post-accident cars, because this is a big problem in all over the world for insurer players and for all the stakeholders.
So you mentioned insurers; they must be, they must love the product, right? Because when an EV actually value is about 40% batteries, really.
Yeah.
It's quite important, I guess, for an insurer to be able to immediately know what the battery state is, right?
Yes, well, that's a big point. And what is interesting, we have talked a lot about China, and we know that on the EV market they have 3 to 5 years. They have 3 to 5 years behind us. But still, insurance players in China, they are losing tons of money on that because they haven't solved this problem. So yes, insurance players are really, really interested in what we are doing, but also in the next future project, because we know that you have 8 years warranty on batteries from OEMs. But still, this warranty does not cover everything. And if you understand that batteries can last 15 to 20 years, you have a big gap there. Yeah, so there's a lot of new warranty that should be sold on the market. So it's also a new product for our insurer player. So, and it's also, of course, linked to a financial situation, because right now the cost of usage of an electric vehicle per kilometer is lower than a thermal one. But still, it's more expensive to buy it, and we don't really know how to repair them. Batteries, not electric cars. But that's more a financial problem than a technical problem.
Absolutely. Just to jump on that one, the second-hand car, you know, the market will also depend on the trust that people have on their battery life, and of course, the state of health. So, car manufacturer, if the second-hand is going through the car manufacturer, the car brand, okay, it's fine, but individual to individual, they want to know what they're buying, and having a clear diagnosis is so important. Also demonstrating, I think, that vehicle-to-grid or such activities are not deteriorating that much, so that everyone is also, you know, they are relieved from that point. Is these technologies are among all the other technologies that are needed to make this happen.
And so your business relies a lot, I guess, on data and analysis of. Is this how you actually create a unique value proposition versus maybe your other competitors elsewhere in China and everything, or do you throw the word AI at every investor, saying, "Look, I'm using AI. It's gonna revolutionize my business"? What's the deal here?
Well, that's an interesting point. But first, we start with physics. We start because we have patent on thermodynamic approach of understanding batteries. So this is a physics approach at the beginning. But you want to combine physics and AI. That's where you create a unique value. That's also why we are starting with the end of life or end of the first life of batteries, because you can have access to this multi-brand data to really understand with physics batteries. And if you combine this unique data set and you start to make magic with AI, you can do real great prediction. Because if you add the two of that, you can do prediction with small volumes of data. Right. Data is something which is really difficult to get in this industry. We have been working with Northvolt and others, and they were not eager to share a lot of data. If you talk to OEMs, they will never share the data, I hope for them. So you need to build your own data set.
One thing you alluded to is the second life of batteries, and your technology really enables that. When we were talking a bit earlier today, you were saying that actually people don't realize that before sending a battery for recycling, actually 90% of those batteries are actually perfectly fine and could be sort of given a second life. What's your take on this second life issue?
You're right. Most of the batteries we have at car dismantlers right now are really in good condition, and they all get to recycling, even if the recycling industry is struggling to be built, but another topics. What we believe a lot is we will be able to use those spare parts for repair. That will be a great topic. But also for second life. What is difficult for second life right now is if you compete with new Chinese batteries, most of the time your second life batteries are expensive than new Chinese batteries. So we need to industrialize that to make it more competitive. I don't believe that will work at scale, except if we get some tariff, some protection from European governments. But even if you don't do that at scale, even if I mentioned that 90% of batteries are in perfect good condition, if you can use 5% of this flow for second life industry, you will transform all the economic of this afterlife value chain. And that's something which is quite important because we mentioned a bit the sovereignty. The after-sales part of OEM is something which is quite resilient and which cannot be exported because you have to deal that in our soil. And that's really interesting to work on that because even if it's BYD or MG batteries, they will end on these afterlife, after-sales players. So there is a lot of opportunities, even not at scale for second life, but still to enhance the actual flow. And we're also working with recycling companies because they know that when they receive batteries, some of this flow can have values. And for them, if 5% of the volumes because you mentioned that, Luc, that in recycling you don't have high margin. But if 5% can be reused, well, the economic is really not the same.
So this is actually a very good transition towards the recycling topic, closing the loop at the other end of the supply chain, really. These activities have somewhat not become too critical yet because a lot of batteries that we're using are still in operations, obviously. But the IEA says that by 2030, the capacity will basically be multiplied by 5 in terms of recycling all over the world. Most of that, again, in China. Surely Europe should build its own recycling capabilities for sovereignty reasons, for metal and mineral recuperation, and reducing the dependence on extraction somewhere else in the world, right? Luc, what will it take actually to build an effective recycling value chain in Europe?
I think the starting point here is that obviously putting so much effort into importing those materials from abroad, putting it into batteries, whether they are imported as a material or a battery or a car, you need to keep these within the region, and then you end up with more sovereignty. Not sure we will be able to control everything, obviously, but it improves a lot the balance. That's the starting point. Now, when you talk about recycling, I think it's important to define what recycling really is. You have 2 main steps. First one, which is the dismantling, and the pre-processing, which ends up with a black mass. That's the easy part. That's the low capex, that's the low barrier part of the chain. And you have the second part, which is the real challenge when you're talking recycling, which is the hydromet treatment of this black mass, where you separate the valuable critical minerals to put it back into batteries or in some other application in some cases. Most often when you hear about battery recycling, you end up with a number of startups which are only doing the pre-processing. And those guys have continued to get funding. So maybe a number on pre-processing would be right ex-China, of course. The China thing, I think, is a different story because all the big recyclers, and the reason why they're multiplying their capacity, are tied to the big battery makers, car makers. And if you look at Brump, that's a subsidiary of CATL. BYD has launched recycling capacity. So again, China here has an integrated approach. And by integrated, I mean from the upstream to the recycling to the second life. All of this makes a system where at some point you can lose money on one end, but you gain on the other. And you keep having this long-term thinking and ability to be flexible. That's what I think is very hard to develop because we do not have this yet. So again, partnering is important. So the number ex-China, I think, are bullshit, let's put it this way. Especially in Europe, when you look at all these black mass processing, I'm just focusing on that part, 2/3 of the projects which were talked about before 2024 have disappeared, been cancelled, or you never know when they will come. There are a few reasons to that. First of all, you had a slower European EV market. But second, and most important, the LFP versus NMC debate. Keeping in mind that all the battery recycling, again, I'm talking the hydromet part, was focusing on NMC extraction because you have cobalt, you have nickel. Lithium is the hardest they can focus on, but I'll come back to that in a second. And so all this part of the chain has come into disarray. So you end up in a situation where Europe today, if you project yourself by 2030, is a net exporter of black mass. So now it's treated as a hazardous material in the regulation. That's new. Regulation is improving. But it can go to Korea. It's a WTO country. That's today where most of the flows are going. I mean, this is a nonsense from an economical, from an environmental standpoint, and that's what needs to be addressed. So I think when you talk about recycling, the big challenge to me is that it's very hard to predict what is the addressable market, because it's a multifactorial parameter. What is going to be the actual EV market penetration? Maybe that's the part where there is more visibility. What's the technical, what is the real cycle life? We were just discussing that. What is the chemistry mix you end up at some point? What is the percentage of LFP versus NMC? What kind of NMC? LCO? I mean, it's multi-factor again. And the behavior. We are talking about that with vehicle to grid, but it's also whether you use more often fast charging. Second life EVs has an impact. Second life batteries also. So the point I'm trying to make is that nobody has a clue as to what is going to be the addressable market, and therefore how to properly size the capacity that is needed. China does not think this way. They create the capacity first, and then they can work with it. So that's a big thing. When you look into the other element, which is the business model, it's different to set up a business model for the treatment of NMC, where you have residual value for the critical metals, nickel, cobalt again, or for LFP, where the only thing which has value, not so much until 6 months ago, was lithium. For LFP treatment, you need to have a gate fee model. It's a very different setup. And battery recyclers on the hydromet are starting to look into that. But again, when are we going to see all these flows of LFP batteries being recycled? Because to me, LFP is the perfect fit for second life applications, for its chemical and physical characteristic. And then you're talking about efficiency of recycling. So I will maybe focus a bit more on lithium from that standpoint, because I think there is a big difference between lithium recycling versus other metals. If you take cobalt, if you take nickel, there are other applications. So you can always think in terms of open loop. Nickel can end up in a stainless steel, or I mean, you can imagine a number of things. For lithium, it's a different setup. 90% of the lithium consumption goes into rechargeable batteries. So if you don't end up with a circular loop for lithium, you end up with landfill. And well, obviously, it's not acceptable. Now, the problem with efficient upgrading of these recycled salts is a very big challenge. We are working a lot with that, and we are working to be able to blend these with virgin material and meet battery regulation, but we are facing a number of issues which ties to the impurities which you are seeing in recycled salts, which are very specifics, very metallics, and battery makers and car makers do not want at all, or cam makers do not want at all to have these impurities set up. So lithium refiners, such as ourselves, but of course there are a number of projects, need to be included in the loop because they will do the final round of upgrading of these lithium salts, blend it, and I insist on the blending portion of the equation because I think what is overlooked is the complexity associated with reconciling what happens for a recycler, which face heterogeneous inflows, and therefore cannot qualify into the cathode active material producer supply chain, which face very strict specification and needs to have a steady flow. And all of this needs, therefore, to have an ecosystem which goes together with precursor production, with CAM production, and therefore that's what is the biggest challenge, is that you need to build everything at the same time. And again, this requires, I think, a bit of long-term thinking and not just look into the cost from a short-term perspective.
Keeping in mind that there's also environmental impacts to the recycling itself. The technology is highly polluting. Hydrometallurgy uses lots of
reagents,
chemicals, leaching acids, and all sorts of things that ends up in water and potentially have to be, of course, always thought about from the get-go, right? Do you think, again, do you think we are dealing with this properly at the moment on the environmental side as well? Or?
Well, that's interesting because when 4 years ago, I think when you went to a battery forum, everyone was, all gigafactories, they were tackling about the CO2 impact. Now, if you're going to a battery forum, everyone talks about cost. I think you have seen that, Anna. And yes, when I launched Entroview, it was to have an impact on the climate change at scale. But right now, you have to find economical issue on this ecosystem problem, on this sovereignty. And we also know that OEMs, Western OEMs, are facing a difficult time right now, and it will be a difficult time for at least the next 5 years. And we're not really sure what will be the end point in 5 years. And right now, the ecological impact is difficult to assess, because if you say to a customer, you will have a battery with a lower CO2 impact, but you will pay it 10% more, you don't have a market for this. That's so either we have support from government or things like that. This will be a problem.
I think the CO2 price signal can be something here for basically all the life cycle of the battery, whether for the production and recycling, but also for the second use or for vehicle to grid. You know, if there is, because we didn't talk about how much people gain when they do vehicle to grid. They may gain a lot of money or not, or they have to share, but between few hundred euro per year to 1,000 euro per year. But if you have a push on the CO2 topic here as well, if there's a price out of it, if the car manufacturer incentivized by negative CO2 instead of always being punished for their CO2, that can also help. We just, since the beginning, we're talking about scaling things and the difficulty of scaling it, difficulty to going from pilots or technology to scale, because we need business model, and there's this loop has to somehow be broken by any other type of push that is maybe not economic directly, but indirect. Like CO2 emission impact, and I do consider that we don't see that much importance on that, and it is maybe complicated, I don't know, but in all the CRM Act and everything else, that could be a topic.
And you need visibility, you need framework to establish a business. The problem is that everything is moving now, and you keep having this piece of European regulation, which makes 105 pages or whatever numbers, which goes into the tiny details, sometimes contradict with one another. I mean, it's already a struggle and complex in itself. Why add further issues there?
Well, it seems there's an awful lot to do still. We're getting there. Private equity is here to obviously support this vibrant ecosystem of young startup across the entire value chain. We need to have long-term vision as well to be able to face, and compete with our Chinese friends more effectively going forward. We'll certainly keep all of that on the radar over the next few months and years. This is definitely a very important topic for European sovereignty and industrial independence, as well as for obviously reaching a successful energy transition. We do not have any question from the audience, so I guess from us in the studio, it's goodbye, and I'll see you next time.